I started working on these coach lights about probably 2 or 3 months ago, and I prepared so many footages and data that I wanted to share, and I just realized that it's probably just too much, and I'm going to do a short video just to focus on the important bits and actually just to show what I ended up doing. So I have these coaches. 2 of them came with a set, and then I bought a 4 additional one, a second hand, and the 4 second hand one, they came with this Märklin, what is it, 5605 coach light kits, which basically just pickups for 2 of the wheels, and then a bunch of these basically mounts, which all have just regular bulb in it, and it provides just an okay illumination. Obviously each set has 3 lights, so when you look at the whole light working, you can see that there's 3 separate lights because the light is quite concentrated, and obviously because this is just goes directly off the track, there is no electronics at all, so it ends up being quite flickery because obviously dirt on the track and some other issues. So I thought I can do it better, and I can convert it to flicker-free coach lights, and also use LEDs for better illumination, and hopefully to create something which uses a little bit less power than the original bulbs. So let me show you my original design, which was done probably about 5 years ago. The coach, as it comes from the factory, it has a couple of mounts on the roof which serve to mount the original light kits. And what I did is I created this small narrow strip of PCB, and I mounted 5mm. I think these are yellow LEDs on them. And obviously back about 5-6 years ago, it was really hard to find a proper LEDs, because the LEDs were either yellow or it was like even really bright white ones, and none of them are really good. And the other thing with the 5mm one is that the light is really concentrated, so you can see the circles in the coach, so you can tell that it has 5 LEDs. So I didn't quite like that, and obviously because it's an LED, I had to add some electronics. So there are a couple of diodes on each side just to make sure that the voltage is always rectified, and I added a small cap just to even out the flickering. And so I will show a couple of pictures. So it's really dim. I don't really like the color either, and the flicker-free mechanism just doesn't work. So that was my first approach, and that's what I wanted to upgrade now. So this is version 2. Well, first of all, I wanted to get rid of some of the wires. So this time I neatly fed the wires through under the seats and just along the wall, and all the electronics is hidden in the loo. And as you can see, my homemade PCB has been changed to just basically 2 strips of LEDs, or 2 pieces of LED strips. And I choose LED strip because of a couple of reasons. First of all, it's really easy to find, especially nowadays, warm light LEDs. So they give, I think, realistic color. Because these are SMD LEDs, they have probably about 120 or maybe 160 degree of light. So it's not a spotlight at all. It really scatters in the entire coach, so you can't really tell how many LEDs you have in the coach. So it gives a really nice even light. But because I'm using LED strips, there are a couple of things that I needed to do. So obviously, because it runs off 12 volts, I just had to make a little bit of circuitry just to regulate the voltage, which is about 21 or 22 volts for the Märklin digital system. And I also, learning from the mistakes from my previous design, I added a bigger cap to to make sure that I have a flicker-free operation. Because there are so many different models on the market, LED strips, I think it's fairly difficult to choose the right one. So these two that I just happen to have at home, just to show the differences. So obviously you can get one which comes with some sort of protective silicone coating, which is good for waterproofing, but I don't think that's really required inside the coach. So I chosen this one which doesn't have any coating. And obviously you can buy ones which are RGB. This happens to be an RGB one, which again I don't need because I don't want disco lights in my coaches. So obviously I went for the white one, and I went for the warm white model. So I think nowadays you can get natural white and cool white and warm white. So I guess you just need to pick one which suits best for your coach. For a white LED, you need actually two wires. You need a positive and a negative one. And this happens to have 4. And so I looked up the different labels. So this one says plus 12 volt and this one says RGB. So I think what they have done in China is they just reuse the RGB, this flexible PCB strip, and instead of mounting an RGB LED on that, they mounted a white LED, but basically this white LED consists of 3 small LEDs in a single package. So if I connect the wires to here, it lights up one of the LEDs, so it gives like 1/3 of the light. And if I get 2, then 2, and then all 3, then I have basically the full illumination. So I connect 12 volt here, and then I just basically short all these 3 and connect the ground to it. And again, for different strips, you would just have 2 terminals, one for the positive and the other one for the negative. And as with LED strips, you can cut them in, these intervals. So you can divide it up to a set of 3 LEDs, no matter what model you go for. And so one obvious difference between these two here is you can see the spacing of the LEDs. So I think this one is what they call the 600 because it has 600 LEDs in a 5-meter reel, and this is probably I don't know, maybe 150 or something like that. So it has much more spacing, and that's what I wanted because as you have seen in the previous shot, I have 2 of these groups in a coach, and even 6 LEDs give probably just too much light for me. I mean, it's much lighter, much brighter than any of my other coaches, and but well, that's what I had at home, so that's what I started using. So it works okay for me now. But because I have this particular design, which actually consists of 3 separate LEDs in one single package, I might just decide to disconnect one of them and then reduce the illumination by 1/3, which I might do in the future, but I'm happy with it at the moment. So next, let's talk about the electronics. I only need these 4 components to make the electronics for these coach lights. So the first one is a bridge rectifier, and I'm not sure if I can get it to focus. Probably I can't. No, I can't. So basically what it does, it has 2 terminals which are marked with a small AC sign. So you connect the leads from the track, and what it does, in the other 2 terminals, it basically just makes sure that you always have the positive and the negative voltage coming out of this bridge rectifier. And obviously this is important because even in analog mode, once you reverse, then your polarity changes and your lights wouldn't work any longer. And for digital, the polarity changes all the time, so you need a bridge rectifier, otherwise your light is just not going to work, or it's just going to be really dim. So the second component is a voltage regulator. I really like this one. I think it's a 7812, which basically 12 stands for voltage regulator, which regulates to 12 volts. And it is really simple basically on this pin you connect the positive input voltage. This is common ground, and in the right pin it's 12 volts. So the negative from the bridge rectifier comes to the middle one. The positive goes to the left pin, and then we will use the right pin for to go to the LEDs. The next one is this small cap, which is, I think it's 100 nanofarad smoothing cap, and I didn't include it in the design originally, and when I tried it, it had, the whole circuit had a sort of like high pitch frequency, which comes from the switching frequency of the digital system. So I was told to use this smoothing cap, and basically that goes in between the bridge rectifier and the what's this? The voltage regulator. And then finally you have a big cap, which is to do the smoothing and just to make sure that it's the LEDs are flicker free. And that's a 16 volt and 2200 microfarad cap. And what it gives me about a second full illumination, and then it slowly fades away in another 2 or 3 seconds, which is just enough, or maybe just more than enough for just to ensure that the lights are flicker free. So when the coach are rolling, I get constant illumination. I don't get any flickers at all. Obviously, if the coach stops on a dirty piece of track and it stops picking up power from any wheels, then obviously the lights will fade away. And it's really easy to pick any of these because, I mean, obviously for the caps, you just, for example, you buy this one for 2200 microfarad and you just buy the voltage which is above 12 volts. You buy this one again, something around 16-20 volts. I think this one is again quite standard. It goes up to 35 volts and 1.5 amps, and probably this bridge rectifier is again 25 volts, 1.5 amps, which is so all of them are above the rate we are going to use for this application. These are my these are the circuits. So I have 6 coaches. I think I've installed the lights in 3 of them, and I obviously made the circuits for all 6 of them at the same time. So I just need to finish the installation. I use this perforated board which has holes drilled at, I think it's 0.1 inches. So it's the standard stuff, and then it has a little bit of copper for every single hole. So it makes it really easy to well, basically the wiring on the other side is quite a lazy job. So I poke the components through the holes and I just solder them, and then I had a piece of just a plain wire and just connected the different terminals. And what I have ended up doing as well is just to make it really easy to service this is I added these I think these are called the pin headers. Well, actually these are the pin headers, and these are just like jumpers with the wires on that you can solder into the board. So this one goes to the track, and so as you can see, the 2 leads go into the 2 terminals of the bridge rectifier, and then from the bridge rectifier it is connected to the voltage regulator again. The plus goes to the left, the ground goes to the middle. In between the 2 I have the smoothing cap, the smoothing cap soldered, and on the other side of the bridge rectifiers again the ground is common, and then that's the regulated 12 volt, and sorry, no, it's the other side, I flipped it around. So that's the common ground, that's the regulated 12 volts, and in here I have the large cap for flicker free, and then I get a piece of wire just to connect it up to this terminal, which then goes to the LEDs. And usually it's the other way around, because the pin headers are soldered into the board, and then the connector is this type of, you know, female type. But I did the first like this, and after I realized it, I thought I'd just carry on with this kind of layout. And I do have a couple of LEDs here, so I mean, it's really easy just to connect it. Yeah, just plug it in, and you know, plug one in for the connection to the rails, to the pickups, and the other one for the LEDs. And you can also you can always take this out, you can unplug it, and so it's much easier to maintain it later on. Just to be on the safe side, I've added a really small heat sink to the voltage regulator. So obviously the voltage regulator heats up, but the heat which is generated depends on the voltage difference between the 12 volts and the input voltage, and also the number of amps. So because this is rated to 1.5 amps, and my circuit uses probably around 100 milliamps, it's not going to heat up. But again, it's in the coach and in the loo, which has no ventilation, so I thought it's you know, just better to have a bit of heat sink, and obviously it still fits in the loo, so you know, why not add that to the board. Let me show how the pickups work. That's the one which is the Märklin factory pickup. It's basically a piece of plastic here which clips in between the wheels, or in between these basically holders or whatever, and there's two brass pins which push against the inside of the wheel, which obviously creates a little bit of drag, and sometimes it's also noticeable because it's, you know, squeaking. And then there are two clips on each of the terminals, and there is a hole which again comes like, you know, out of the factory. So you just have the two leads connected each of these terminals, and then you have exactly the same on the other wheel. So two of the three wheels pick up power. So I use different color wires just to make sure that I connect, you know, the blue one is always this one and the red one is always this one. So it's easy to do the same on the other side, so I don't create a short circuit with the coach. And this is my original coach, which has pickups which I designed. It's relatively similar design. This is a piece of PCB which I milled away the copper from the middle. I drilled a hole, and I used this screw to screw it onto the well, it's not really a bogie, but it's just like, you know, like a single wheel bogie or something. And these flanges here, or, you know, piece of metal, is, I think it's called a phosphorus bronze, which has like a springy characteristic. So it works like a, you know, small spring. And I basically just bent it 90 degrees, soldered the wires and everything onto the copper plate from the PCB board, so it creates connection, and also it secures it into this board, which then screwed onto the chassis. And again, it just picks up wheels against the picks up power against the back of the wheel, or presses against the back of the wheel, and this is how it picks up the power. Again, it creates drag just like the original Märklin design, but it seems to be working really well. I mean, occasionally there are issues. I'm trying to get this one into focus, but as you can see, this one is bent away, so that one is definitely not working. Oops. Okay, I just broke it. But the other one is still working. As I said, I have 3 coaches left, so these are the strips for the last 3 coaches, and these wires are for the pickups for the wheels. I've already soldered the pin headers on, so it's just a matter of assembling the everything, you know, together. And in order to mount the LEDs to the roof, I just cut a piece of plastic card, and I drilled 2 holes, so I'm going to use this, so that's the piece of plastic card. I drilled 2 holes. I'm going to use the screws from the Märklin kit to mount it onto the roof, and then the strips go onto here. And you know, because these are Chinese stuff, and sometimes I guess by the time we get it in retail, it could be sitting in a warehouse for a couple of years. So what I found is this double-sided tape at the back, it just, you know, really useless. So in most cases it just peels away after a couple of days or weeks. So as you have seen on the previous footage, I used a piece of, well, basically 2 cable ties to, you know, to wrap around this piece of plastic. And I'm not even using the double-sided tape at the back. But this is something that I just found. I mean, it might not be the case for all of these LED strips. So obviously the reason I cut these 2 groups, because I thought that, you know, 6 LEDs provide enough illumination, so I didn't want to use, you know, a longer strip of 9 LEDs because it would be too much. And probably it was visible on the first video that there is a component divider in the coach, and there is only limited space between the roof and that sort of divider, so it's much easier to fit the 2 wires through that confined space than, you know, fed through the whole strip. But again, it was mostly for the light reasons, just to make sure that I have enough light and not too much. And probably you can see here that, so my red is my positive, so that goes to the plus 12 volt in this case, and then the blue one, it just soldered onto these 3 terminals at the same time. And that's it. Actually, it's rather simple. Just for comparison, I've created, I took this picture when I had all 3 of the different versions in place. So there is one with the factory fitted lights with the regular bulbs. The next one is my old design with the 5mm LEDs, and the last one, obviously the brightest one, is the one with the LED strips. So you can really see the difference. I mean, you can judge it for yourself whether the latest version is the best one, because it's, yeah, probably too bright. But in terms of the flicker-free operation, it's definitely my favorite. That's all for now. Thanks for watching.